To start Chapter 6, we're going to talk about quadratic graphs and their properties. This is definitely probably going to be the longest note video that we do all year, so make sure that you have that guided note paper out in front of you to help you along with the notes. So a quadratic function is anything with an x squared being the highest power. So y equals x squared is the most basic quadratic function that you could have. It's going to look something like this, and we call that U shape a parabola. Now, that bottom point there is the vertex. We call that either a min or a max, depending on whether it's the low point or the high point. And then we call the axis of symmetry that vertical line that would be going through the vertex. And think of it, if I folded the parabola on that line, it would perfectly cut it in half. And remember, any vertical line is x equals a number. It's always going to be x equals the x-coordinate of your vertex. So, kind of as we were talking about with vertices, the highest or lowest point of a parabola is its vertex, which is on the axis of symmetry. So if a is greater than 0, or if it's positive, the parabola opens upward, and then your vertex would be a minimum. If a is less than 0, the parabola opens downward, and your vertex is a maximum. Now, just as a recap from last chapter, remember your a is that coefficient that's in front of x squared. So remember when we did factoring a, b, and c, whatever number is with x squared, I'm going to focus, if it's positive, I have something that looks like it does to the left. If it's negative, I have something that looks like it does to the right. So number 1, I want to find the vertex of each graph. And then I want to know, is it a max or a min? So here I have your 3 graphs. Now this first point here, I see that the vertex is -1, 1. Now it's the lowest point of the graph, so I would say that it's a minimum. In our next graph, we have the point 2, 2, looks like it's the vertex there. Now that's the highest point of the graph, so I'm going to call that a maximum. Then finally in our third graph, -1, 0 looks like the vertex, that's a low point, so I'm also going to call that a minimum. Now in number 2, I'm going to look at the same graphs. Now I want to know what is the axis of symmetry for each. So it's going to be that vertical line going through the vertex, and that vertical line in that first graph would be x equals -1. Notice how x equals -1. -1 is the x-coordinate of our vertex as well. In our next graph, the axis of symmetry would be x equals 2. And in the last graph, our axis of symmetry would be x equals -1 again. So moving along, the a value also determines the width of a parabola. So the higher the a value, the more narrow the graph, so like the skinnier that u is. So we're going to start with y equals x squared. Our a value here is 1, so that's kind of, again, the most basic parabola that you can have. If I change that number from a 1 to a 2, for example, again, my pictures aren't perfect here, but do you notice here that graph or that u shape gets a little bit skinnier? And then if I made it y equals 3x squared, it gets even skinnier from there. If I went the other way, what if I wrote the graph y equals 1/2 x squared? Notice that the higher the a value, I get more narrow, and the lower the a value, or the closer to 0, the wider it gets. Last key feature of a quadratic graph are going to be the zeros, which we also call x-intercepts. So again, the zeros are the x-intercepts on the graph, or where you're crossing the x-axis. And since they're a U shape, a lot of times you'll have 2 x-intercepts or 2 zeros. So in example number 3, I want to figure out what are the zeros of the following graphs. So in this picture, or in these 3 graphs. So here I cross the x-axis at -1, 0, and 2, 0. So those are my x-intercepts, or again, we could call those zeros. Notice in this graph, I only touch the x-axis once. So I'd say that there's 1 x-intercept, and that's at 1, 0. And finally, in this last graph, I don't cross the x-axis at all. So there's none. There's no zeros there. Now, this is going to be important. We're finally kind of getting towards the end of the video here. There's 3 different ways that you could write a quadratic equation. The first is standard form, which is ax squared plus bx plus c. Next is vertex form. This one's going to look a little bit newer. F of x equals a times x minus h squared plus k. The h and k represent the vertex of the graph. And finally, factored form, f of x equals a times x minus q times x minus r. Now, and q and r would be the zeros of the graph. Now, we've worked with standard and factored form because that's kind of what Chapter 5 was about. And you'll kind of see how that math goes into this stuff later on in the chapter. A lot of times you're going to be given a graph in standard form. That's the hardest to graph by looking at it. So if you're given something in standard form, we'll put it into Desmos and then write it out in vertex or factored form. So vertex and factored are going to be what are going to be the easiest to work with on our graphs, and that's going to be kind of what we use a lot to graph things. So here I want to write an equation for the following graph, and here I have the equation here. So I'm going to go ahead and notice here, there's no zeros, so vertex form is going to be the easiest to graph. Why? Because there's no zeros, so writing it in factored form wouldn't really make sense. So I'm going to use vertex form because clearly it has a vertex. Vertex form, again, is f of x equals a times x minus h squared plus k. And here's where I have to plug stuff in. Now my vertex is at 2, 3. 2 is going to be our h value, and 3 is going to be our k value. So I'm going to plug in a 2 and a 3. Notice how the sign changed for the x-coordinate, but not the y-coordinate. That's going to be something that's kind of weird about these graphs. Last thing I got to plug in is my a value. How I do that is I'm going to count up and over from the vertex, or down and over, then it would be negative. But here I count up 1 over 1 to get to the next coordinate, so my a value is 1. So my graph would be f of x equals x minus 2 squared plus 3. Now let's look at one more. I want to write an equation for the following graph. Now here, I could write this in vertex or factored form. I have zeros here, so let's just do factored form just to see the difference. Here I have x-intercepts at -1, 0, and at 3, 0. And the -1 and the 3 are going to be what I use for my Q and R values. They're kind of interchangeable. So remember, factored form is f of x equals a times x minus q times x minus r. I'm going to plug in -1 and 3 for Q and R, and again, it doesn't matter the order. So I'd be plugging in x minus -1 and x minus 3. Remember that minus and negative turns into positive. And then finally, to find my a value, notice here that since I'm going down, my a value is going to be negative. I need to count down and over. What's kind of weird about this one, looking at your graph, I start at 1, 2, and then the next coordinate over, or like my y-intercept, is 0, 1.5. So I go down a half and over 1. So my a value here is going to be -1/2. And putting that all together, I don't need to kind of simplify anything there, and I would be done.